my dear student. I'm Mr. Twala from Educatiz. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion for our topic of wave for the subtopic of the wave motion. So I would like to invite you, my dear student, for these discussions. Now, before we proceed with our discussion, we should remember where we ended on the last session. On the last session, we tried to discuss how can we obtain the formula, the displacement, also the velocity for the stationary wave motion. Imagine we have the two waves, the two progressive waves, and those two progressive waves, they have the same amplitude, the same frequency, and they try to move in the opposite direction. Now, how can we obtain their displacement, their net displacement, my dear students? So we said that this can be obtained, my lovely student, by consider the direction of those particles. It means if the particles starting from the left, then move toward the right, we should obtain their formula. And also, if the waves are moving from the right and they are then toward from the right toward the left, we tried to demonstrate their formula, and finally we tried to apply the concept of the trigonometric transformations. Trigonometric transformation, I think. We tried to use that concept, and finally we obtained that we get the displacement by taking 2a, 2 amplitude, 2 times the amplitude times the cos kx, then we times it by the sine wt. That is the formula that we demonstrated on the last session. And after there, we see some examples related with what we learned. So this is the time to look about the stationary wave on the string fixed at both ends. Assume we have this we have two ends. We have two fixed points. Then we take the string and fix it at one end, and also the same way we take the second ends of the string and fix it into the other point. Now, what we could obtain, how the stationary wave can be formed on that string, is what we are going to discuss on our today discussion here. So we have been told that a stationary wave generally has no velocity. We know that always this stationary wave, my lovely student, doesn't involve any velocity. It doesn't contain a velocity, my dear students. So since there is no energy, kwa sababu hakuna energy pale ambayo tabini stored, bali tabini transformed from one point kwenda point nyingine, lakini kutakuwepo na energy at one end kama tulivyosoma kwenye statements zilizopita. Kwa sababu hakuna hiyo idea ya energy ambayo tabini transformed from one place into another point, then tutaassume kwamba hakuna velocity yoyote, my dear students. So as we say that there is no energy transmission between the nodes, kwa sababu the particles atakuwa na move, atafika kwenye nodes, atashuka, atamove, na mwingine ikifika kwenye node pale yule particle, yule energy atabini cancelled. Hakuna energy ambayo tabini passed from one node kuelekea kwenye node nyingine. Kwa kila kipande kinakuwa na energy yake ambayo kitaistore pale, lakini hakitaiweza kuiconvert kutoka sehemu moja kwenda sehemu nyingine. But a number of wave of different frequency. Sasa tuangalie kwenye number of wave of the different frequency. The wavelength and also the velocity may superpose to form a group. Kwa hao sasa tutaona kabisa kwamba this velocity, this wave of the number of wave of different frequency pamoja na wavelength and this velocity may superpose. Kwa hizi hapa zitajaribu kusuperpose kwa lengo la kutengeneza the group of the aims of forming the group, my dear students. So after there, we have been told that motion of such a group is called a group velocity. Kwa ile motion of such a group tutaita ni group velocity, my dear student, which can be considered in a stationary waves. Kwa hiyo itabidi consider it in a stationary wave, my dear student. It can be produced by the vibrating string. Kwa hiyo ile string inapokuwa na vibrate pale ndio itaweza kutengeneza ile stationary wave, my lovely students. So after there we have been told that we should consider a string of length L. Now imagine we have the string and that string contain the length L, my dear student, between the two fixed point. Kwa hiyo na length L, lakini ile length L inaokaa katika fixed point B, the first fixed point and also the second fixed point, kutoka kwenye point moja kwenda kwenye point nyingine, ndio kitu ambacho kinazungumziwa pale, my dear students. So then pluck at the middle point. If we pluck at the middle point, my dear student, the wave will travel in both direction. Kwa tukichukua sasa, tukienda pale kamba yetu ile string tumeifunga katika pointi mbili, tukaenda kwenye middle point tukajaribu kuipluck. Ukishaiplug pale anakuambia kwamba zile wave zitaweza kumove in both direction. From the middle, it means from the middle, some of the wave they move toward the left side, and the other they move toward the right side, as we have been told according with our statement, my dear student here. So and will be reflected at each end as it shown in the figure here. Kwa hao watakuwa watabini reflected, tabini reflected zile particles as at each ends as it shown in the figure number 80.8. So as adjacent nodes of the standing waves here. Kwa yule sasa tunasema kwamba ili tuweze kumpata yule adjacent nodes kwenye ile standing waves. Adjacent waves can be expressed at the wavelength divided by 2. Ndo namna ya kuweza kupata ile adjacent nodes as we have been told, my lovely student. And this occur apart. Kwa huyu wavelength yetu atakuwa ni, it means kwamba adjacent nodes atakuwa ni nusu. It means kwamba we take a half divided by 2 apart, kutoka sehemu moja kwenda sehemu nyingine. So then wavelength of the first, second and also the third harmonic. Kwa yule wavelength of the first, the wavelength of the first, the second and also the third harmonic of the string is expressed as it is shown on the next slide. Kwa hiyo tuweze kupata sasa kwamba how can we indicate, how can we represent the wavelength of the first harmonic, the second harmonic and also the third harmonic, my lovely student. If we have been given at the adjacent standing waves, their wavelength must be a half, as we have been told here, my lovely students. So there we should say that now the length must be equals to the wavelength. It means kwamba kwenye first note, kama tulivyoambiwa kwenye first harmonic, ituweze kumpata yule length atakuwa ni sawa na wavelength 1 divided by 2. Kwa yule is equal to wavelength 1 divided by 2. While for the second harmonic, we obtain the length by taking wavelength 2 divided by this 2, my lovely students. And also for the third harmonic, tutampata huyu wavelength huyu length is equal to 3 wavelength 3 divided by this 2. Kwa hizi ndio variation ambazo zitatusaidia kuweza kutafuta ile length kwenye ile stationary waves, lakini kwa kuconsider their harmonic, first harmonic, third harmonic and also the third and also the third harmonic and so on, my dear students. So therefore if lambda n is at the wavelength of the n stems, kama yule lambda n atakuwa ni wavelength of the n stems, hapa there is the type in error. This it means that this is the wavelength, my lovely this is the lambda n, my lovely student. Kwa hiyo kama tulivyoambia kule with our statement kwamba huyu kwa tuta conclude kwa kusema kwamba lambda n atakuwa ni wavelength of it must be the wavelength of the nth harmonic. Then we should express it by saying that this wavelength of the wavelength with respect to n might be equals to 2n to 2l divided by n, my dear students. Kwa kama tulivyoambiwa hapa kwamba for the incidence ambao yule for the number of for the lambda which for the lambda respectively to n, huyu ambao ana express the wavelength at the n stems. Now we should express by saying that the wavelength at the centane value, it means kwamba tunapokuwa at the n stem must be equals to L 2L divided by the number of those wavelengths, where n express as 1, yule atavali sasa atakuwa ni 1 2 3 mpaka atafika the n stems na kadhalika kama tulivyoambiwa hapa. And this will be the question number 21 for our topic number 8, my dear students. So the frequency Fn of the NC, yule frequency Fn of the NC terms of the NC harmonic is given by this one. How can we get the frequency for them? How can we get the frequency n for the NC harmonic, my dear student? We should obtain the frequency n for the NC harmonic by taking V divided by this wavelength n. Kwa tunampata Fn is equal to V divided by the wavelength n, the wavelength n as we seen here. And this would be the equation number 22 for our topic number 8. So by saying that, my lovely student, let us stop here. We could come and proceed with the next part.